In this video, we're gonna find the point of intersection of two circles. First circle is the circle centered at 1, 2 and having radius 1. The second one is the circle having radius 1 and centered at 2, 1. Okay, what we do is we write the standard form of the equation of the circles and we equate them. Let's do that. For the first one, we have x minus 1 squared plus y minus 2 squared equals 1. For the second one, it's x minus 2 squared plus y minus 1 squared. We equate these two equations and we subtract to get x minus 1 squared minus x minus 2 squared plus y minus 2 squared minus y minus 1 squared equals 0. Now we use the famous identity a squared minus b squared is a minus b times a plus b. Okay, we use it here here in this case a is x minus 1 and b x minus 2. Here x is y minus 2, a is y minus 2 and b is y minus 1. So let's do that. We get x minus 1 minus x minus 2 plus 2 minus y minus x minus 1 minus x plus 2 times x minus 1 plus x minus 2 plus y minus 2 minus y plus 1 times y minus 2 plus y minus 1 equals 0. Okay, so here we get a 1 times 2x minus 3, but here we get minus 1 times 2y minus 3 equals 0. So this will reduce the equation to 2x minus 3 minus 2y plus 3 equals 0. That means we have 2x minus 2y equals 0, which means that x is y. Okay, now we have x is y. We're gonna go back and plug it in one of these two equations to find x, and after that we go and set the result for y. Or we can do y in one of the equations, but we will do it for x. So in the first equation, we get x minus 1 squared plus y minus 2 squared equals 1. So here we plug y equal x. So we plug x here and we solve. So we have x minus 1 squared plus x minus 2 squared equals 1. So now we expand, we get x squared minus 2x plus 1 plus x squared minus 4x plus 4 equals 1. So we get 2x squared minus 6x, and the 1 cancels with this one here to get 4. So we have 2x squared minus 6x plus 4 equals 0. Divided by 2, we get x squared minus 3x plus 2 equals 0. Okay, now we solve for x. So we split these 3 as follows. So x squared minus x minus 2x plus 2. This trick always works if you see what you want to do. So here we have x times x minus 1 minus 2, x minus 1. So we have x minus 1 as a factor. So we have x minus 1 times x minus 2 equals 0. That means x equals 1 or x equals 2. That means the points, the first one is 1, 1, since we found that x equals y, and the second one is 2, 2. So we have 2 points. Okay, so this is how we find the points of intersection of two circles. And this case we found a solution. It's not always possible. So when we have two circles, they can either intersect. Okay, they can either intersect in 2 points or in 1 point when they are tangent. They can have no points, they don't intersect, or they can have absolutely many points, infinitely many, when they are on top of each other. Okay, so I have drawn in these circles by hand, and this is what they get. Okay, so this is our point 1 1, and this is 2 2. So, and these are the circles. So the first one is centered at 2 1, have a radius 1. The second is centered at 1 2 and have a radius 1. So these two circles intersect. Why are we interested in this point of intersection? So assume that we want to find the area here. Okay, so, and sometimes it's not easy to find, but using calculus we can find the area. So we know our x here is 1 and 2, so we can say the area is between 1 and 2. And can we find this one here? Yes, we can solve for y and find this part. We can solve for y and find this part. Assume that this top here is expressed as f of x, and this one is expressed as g of x. The area in this case is f of x minus g of x dx. Okay, since both of them are positive, we get rid of the absolute value, and the area here is just between 1 and 2 of f of x minus g of x dx. Okay, so this is the area. This is one application. Why are we are interested in finding the points of intersection. Okay, maybe we're gonna come back and see what we can do in some very serious circle intersection. But for now, this is all we need. Thank you very much. If you have any questions, post them in the comment section. I'll be more than happy to answer them.